Okay, this is Hydroxy. What are we up to? 1.5? 1.6. That's because I put it back together. So 1.6 vacuum test. And what do we have? We have the power supply, the cell, and the vacuum chamber. And we're going to go ahead and turn this on. And you're going to be able to see we're running just over half an amp at, I don't even know if it'll focus in, at 3 volts. And we're not talking a huge reaction here, but it's still going to show what I want it to show. And you can see the bubbles. Very slow, but that's what I want to show. So as you can see, the system running, it's pretty much normal. It's at room temperature. Now I'm going to shut it off. Okay, now we're going to pump all the air out of it. And we're going to go to 15 inches of vacuum. There. Oh, one more. Okay, as you can see, 15 inches of vacuum, no bubbles in the container. Just zoom in on the, no bubbles in the container. So we have a completely vacuum sealed system at 15 inches. And now I'm going to turn the system back on. My son's doing the sound effects for us. Okay, so as you can see, 0.67 amps, 3 volts, system's running, and there's our bubbles. There's basically no difference. What I've come up with is once the solution is saturated, it releases the bubbles. The only benefit you get from vacuum is when you first apply the vacuum to it and it pulls whatever bubbles are out of the water into the air to fill the space. But once the vacuum is established and the system is running, there is no difference. It's still the same production that's coming from the cell. I hope this clears things up. I'm pretty sure there's going to be a lot of questions around it, but I hope it clears it up. By the way, the solution is room temperature, and it's a 10% KOH. What am I looking for? Just 10% KOH. And again, 6.65 amps at 3 volts. Pretty stable. And it'll run all day long like this. Okay, that's vacuum concept. Okay, vacuum concept part 2. I just realized that people would say that if you had a higher amperage running with more gas bubbles in the solution, that the vacuum would make a better effect by pulling the gas bubbles out of the liquid solution. And I just wanted to let you know I have tested that, and as you know, we were testing at 0.64 of an amp at 3 volts, and we're going to kick this up to 12 volts at 8.75 amps, and this is going to keep climbing. This will go until I hit 11 amps and it shuts off my power supply. So I want to let you see the reaction. By the way, this is 2 plates at a 1/16 of an inch spacing in 10% KOH solution at room temperature. There's a single hose connecting to here. Now, this is under 15 inches of vacuum, and what I'm going to do is let the vacuum out of the system, and you can make your own judgments. Okay? So you can see the bubbles going now, and we're going to slowly let the vacuum out so it doesn't dilute my KOH solution, because it will pull water back into the cell quite rapidly. And what I'm doing is I'm hitting the pressure release button. These vacuum seal containers make great tests on this. Okay, so now we're back to the bubbles again. We're up almost to 10 amps, so that's the difference in our production, but I'm going to let you know that, hey, there's no vacuum here. So it can't be because of the vacuum. Alright, thanks for watching. We'll keep trying stuff until we figure out what works.